Hello, good morning, good evening, and good afternoon to any part of the country or the world. This is now another topic of how to deal with simplification. As you can glance with our slide, we have here relative to the rational exponent. Okay, hold on yourself and keep on watching. Here are the tips in how to deal with this given simplified expression. We are going to simplify this with the example 4x cubed times the quantity of 3x squared plus 2 quantity raised to the power 1 half subtracted to x raised to 4 times the quantity of 1 half times the quantity of 3x squared plus 2 quantity raised to negative 1 half times 2x all over 3 quantity 3x squared plus 2 raised to 1 half raised to 2. So before we go further to the proper discussion of the given simplified expression, so we're going to recall first what we have learned regarding to how to factor the polynomial. Okay, let's have a given example for number 1, 4x squared y to the 6 z squared plus 8x cubed y cubed z raised to negative 1 minus 12x raised to 5 y squared z cubed. For us to be able to get the factor of this is we're going to find first the greatest common factor of every terms that we have. Take note in the given number 1 we have three terms that we have. So the first thing that we should do is just to work for this the numerical coefficient of every terms. So as we cater for that is we have to get this common multiple of this. So we have here 4, this common multiple of 4, 8, and 12. So the common divisor of this is 4. All of the numerical coefficient is divisible by 4. So we have here 4 divided by 4 is 1. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay, this one is what you call this as continuous division. So therefore, we have since we don't have any more common divisor aside from 1, so the GCF that we have is 4. So in this case, we have now the common factor of the numerical coefficients that we have is 4. What we will do for the literal coefficients of every terms that we have. Okay, in dealing with this expression or the literal coefficients, all we have to do is to identify first what is the lowest value of the given exponents of every variable given. So we have here x squared in the first term, x cubed in the second term. We also have x raised to 5 for the third term. Again, x squared for the first, x cubed for the second, and x raised to 5 for the third. So among the three, the lowest exponent is x squared. So we have now get out. So the x squared, that is the GCF given of the variable x. Then for the variable y, we have here y raised to 6. We have here y raised to 6. We also have y raised to 3 and y squared. Among the exponents of y, we have here y squared as the lowest exponent. So all we have to do is just to get the common factor, the GCF of the variable y. So its GCF is y squared. Then we have z. In z, we have here z squared, z to the negative 1, and z cubed. Again, the lowest exponent. So among the Among the z squared, z to the negative 1, and z cubed, the lowest exponent is z to the negative 1. So we're going to have that one as our GCF. So get out that one and put it in the other side, on the first factor. So what would be the value of the remaining numbers or the remaining terms in the expression that we have? So since we have here 4 for the numerical, so we have now the numerical coefficient of the first term is 1, x squared. So since we removed already the x squared, so we have now x squared. No, we don't have anymore the x squared. Wait. So I just erase this one. So we have no x squared anymore. So we have now here for the y squared, since the first term is the y, we have y raised to 6. So therefore, since we remove already the y squared, so what is remaining for y is y raised to 4, because 6 minus 2, because we have to divide y to the 6 over y squared. So y to the 6 divide y squared, so we have to subtract 6 minus 2 for the exponent, since the exponent of the denominator is bigger than the exponent of the numerator, so we are going to subtract them. So 6 minus 2 is 4. So what is remaining now for the y variable is y to the 4. Okay, so I have to erase this one. So we have also, okay, and so we have for the z is, so 2 minus negative 1. So what is 2 minus negative 1? So we have here 2 plus 1. And so we have here equivalent to 3. So therefore now here in z we have z to the cube. Why we are going to subtract them? So as from the given example previously, y to the 6 is, since we just divided it to y squared, so we always just subtract the exponent. So same thing that we should do in the y squared. So 2 minus negative 1, because the negative 1 is our subtrahend, because that is the one of the factors outside on the remaining terms on the second factor. So that is why we have here z cubed. So z cubed, then we have here plus, okay, raise. That is how we cater with our situation or with our problem that we have in dealing with the negative exponent as the common factor. So in the second one, in the second term, so 8 divided by 4, so we have here 2 y cubed, x cubed rather. So we have here 3, and the outside factor is x squared, so 3 minus 2 is 1, so we have here x to the 1 as the exponent of x. Then for the y cubed minus divided by y squared, so 3 minus 2 is, we have here also 1. So the exponent now of y is y to the 1. And then here negative 1, same here in the dynamic, in outside the factor, so cancel. So we have here no z to the negative 1 anymore, so we don't have z anymore. Then we have on the other side, on the other term, is since subtraction, so negative 12 divided by 4, so we have negative 3 as the quotient. Now we have x to the 5. So x to the 5 here, x to the 2 as the outside factor. So x to the 5 divided by x squared is we have here 5 minus 2 is we have here x cubed. Then y squared, so we don't have any more y here because it is equivalent to 1. Z cubed minus negative 3, z cubed divided by z to the negative 1, so therefore we have 3 minus negative 1. So that is the basic terminology or the process in dealing with getting the common factor of the polynomial. Since the given now here for number is get the common monomial factor. So here we have now 3 plus 1 because negative negative is positive. So 3 plus 1, so 3 plus 1 is 4. So what is have here for z is raised to 4. So in this case now, take note that this one is very much important in dealing with rational exponent because in this is in our proper topic we are dealing with exponent, fractional exponent. So therefore we have to understand or we have to review ourselves in dealing with how to factor polynomials. So we have now as the answer, the final answer now is we have 4x squared y squared y to the 4 times y to the 4 z cubed plus 2xy minus 3x cubed z to the 4 all over z. Because why we have to bring down the z, as we can see that the exponent here of z is negative y. So in simplifying further, we don't have negative exponent as we deal with the given. Okay, so that's it. So this is now the totality of the answer that we have in our given problem number 1. Again, the answer for number 1 is 4x squared y squared times the quantity of y to the 4 z cubed plus 2xy minus 3x cubed z to the 4 all over z. So let's proceed now to the next example. So the given example for number 2 is we have 18x a raised to 4 b raised to 3 c raised to 5 plus 24a squared b to the 4 c to the 7 plus 36a raised to 5 b raised to 8 c raised to negative 2. So the first thing that we should do is that we're going to find the GCF of the numerical coefficient, which having a values of 18, 24, and 36. So we have now to make use of this of the continuous division. So we have here 18, 24, and we have 36. All of the numbers are divisible by 2. So we have now 18 divided by 2 is 9. 24 divided by 2 is 12. 36 divided by 2 is 18. So since the 9, 12, 18 has it has also a common divisor, which is 3. So we have now 9 divided by 3 is 3. 12 divided by 3 is 4. 18 divided by 3 is 6. So we have now 3, 4, 6. So as you check this one, since 4 and 6 is also divisible 3 and 6 is also divisible, but then all we catered with the continuous division is all the numbers must have a common divisor aside from 1. So so then in this given, since we have 3, 4, 6, so we don't have any more a common divisor. So we have now on the other side we have 2 and 3 as the common divisor. So since now we have that, so 2 we are going to multiply them, the 2 and the 3, so we have now the 6. So the GCF now is the GCF now that we have is 6. So therefore in this given, so the GCF is 6 for the common for the numerical coefficient. Now for A, so we have here a to the 4, a to the 4, a squared, a to the 5. So therefore, the lowest value of the exponent of A is 2. So therefore, we have now to remove first for our first factor the a squared, since that one is our GCF for the variable A. And for the B, so we have here b to the negative 3, b to the 4, and b to the 8. So therefore, the lowest among the 3 is negative 3. So we have now to cater the lowest value of the exponent, which is a b to the negative 3. So remove that one, then leave that one as our first factor. Meanwhile, in the C, we have here 5, 7, and negative 2. So therefore now, the thing that we should do is remove the C to the negative 2 as our first factor. So now we have the parentheses. What is left here is in the first, how do we cater the first term of the second factor that we have? So the first thing that we should do is that we are going to have this 18 divided by 6, and that is 3. 4, a to the 4 divided by a squared. So 4 minus 2 is a squared. So we have now that a squared. But then b to negative 3, b to the negative 3, so cancel. So we have now no b here for the first term. Then c to the 5, then c to the negative 2 as our first factor. So c to the 5 divided by c to the negative 2. So again, in this case, we're going to subtract 5 minus negative 2. So I just only share with you the process on how to subtract the negative numbers for us to be able to understand well why it became that 1. So we come up with 5 plus 2. So then we have now C. So now the exponent now that we have is C 7. So for the second one is we have 24 divided by 6, and that is 4. So plus 4 for A. We don't have A here for the second term because we have here A squared and A squared, so it became 1. B to the 4, b to the negative 3. So b to the 4 divided by b to the negative 3. So we have here b minus negative 3. That is 4 plus 3 that we have. So now it is equivalent. The second term expression on the second factor we have now for the b, which is b to the 7. And for c is we have 7, c to the 7 divided by c to the negative 2. So we have here 7 minus negative 2, and we have 7 plus 2, which is equivalent to 9. So therefore, c that we have here now is 9. So for the next term, since we have here the numerical coefficient, which is 36, so 36 divided by 6, and we have here positive 6, so we have here plus 6. Then for a, we have here a to the 5, a squared, so we have here 5 minus 2, and that is 3. So a now raised to 3. And b now therefore is b to the 8 divided by b to the negative 3, so we have now subtract 8 minus negative 3. So we have here 8 plus 3, and that is 11 as we go through with this process. Okay, so we have now the value of our b here for the third term is b to the 11. And we have here c to the negative 2, c to the negative 2, so we don't have any more than 1 because it is cancelled. So this is now the result since we don't have anything we should do. So we are going to finalize then of this. As you can see, we have here two factors of the given expression having a negative exponent. So we have to bring that one to the denominator part, so b cubed c squared. And so we have the finality of this answer is 6a squared times the quantity of 3a squared c to the 7 plus, oh excuse me, I have to erase the c here first because it is not clear. Okay, again, this is c to the 7. We have also 4b to the 7 c to the 9 plus 6, excuse me. So we have here 6 a cubed b to the 11 all over b cubed c squared. That is now the final answer for the number 2 given in our recalling as we get through with the following polynomials. So we are now in the main example that we have been see how to simplify given the expression with the rational exponent, both negative and positive. So as you can see in the given, which is 4x squared times the quantity of 3x squared plus 2, quantity raised to 1/2, minus 4x raised to 4 rather, times the quantity of 1/2 times the quantity of 3x squared plus 2, quantity raised to negative 1/2 times the 2x, all over quantity 3x squared plus 2, quantity raised to 1/2 raised to 2. So in this given example, all we have to do first is we are looking for the things that can be simplified easily. So like for example, we have here 2 and 2 here. So we have to come up with that kind of example. So here we have x to the 4 and x to the 4. If we're going to multiply that one, then here it became x to the 5. So most likely the GCF of the variable x is x to the 4 because we have the lower value, which is 4. So we have to remove that one and make that one as our first common factor. So x to the 4. Then as you can see also, we have two set of terms in the numerator part. Then and the other factor is 3x squared plus 2, the same base on the other term. So therefore in that case we'll be dealing with the binomial term expression having the same base. So we could now have to get the common factor. Then in this case, we have here the first one. In the first term is 1/2 and -1/2 on the other side. So as I said just previously, if we're going to have to get the common factor, or the GCF, the greatest common factor for the both who having the same basis, so we're collecting the lesser value of the exponent. Since the 1/2 and -1/2, the lesser value is -1/2, so we're going to have to come up with as one as the first factor that we have. That's a common factor. Take note that the first factor that we have are those common factor given from the expression. So what we have now here is quantity 3x squared plus 2, quantity raised to -1/2. So we have to remove that one and make that one as our first common factor. So we have now here what is remaining here in the first term. In our first term, as you can see here, so since the x raised to 4 removed as first factor, so what is left here is 4. So we have here 4, and then this one here, since it is 1/2, so 1/2 3x squared plus 2 quantity raised to 1/2 divided by 3x squared plus 2 quantity raised to -1/2. So therefore we are going to subtract further with that, and so we have 1/2 minus -1/2, and so we have here now, so 1/2 now be added to 1/2 because logically we have here double negatives, it became positive. So 2/2, say they have the same denominator, add the numerator, so we have here 2/2, and that is 1, equivalent to 1. So what is left here now, so the exponent of this base 3x squared plus 2 for the first term is 1. Then minus another term, which is this one here. So we have x raised to 4, we just removed that one already, as make that one as first factor. So we have now what is left here is x. Since the lower value is -1/2, so we don't have any more -1/2 as the exponent of the base 3x squared plus 2 because it became now as our first factor. So what is left here in the second term is x. Then all over, so as you can see here, the 2 here and the 2, which is, the exponent, which is inner exponent is 1/2, then we have the outer exponent is 2. So we have the rules in the laws of exponent. If the exponent multiplied to another set of exponents, so we could now have to multiply both exponents. So 1/2 times 1/2, 1/2 times 2 is 1. So what we do we have now is the exponent, as you can go along with the next process, is the exponent on the denominator of the base 3x squared plus 2 will be 1. And if you're trying to analyze further, as we go through with the next step, we could now analyze then that we have a negative exponent. So if we're going to have further to that, so we just able to move it down as our divisor, or as our denominator, because we have a negative exponent, so it must be this positive exponent. So in this case we will be having as, okay, so x to the 4 times 3x squared plus 2 times the quantity of -1/2. How it became 12x squared plus 8? So because specifically we have given previously, which is 4 times 3x squared plus 2. So now 4 times 3x squared is 12x squared. 4 times 2 is 8. So that is why it became now 12x squared plus 8 minus x. So as I said previously, that the denominator, the exponent of the denominator, we have now 1, obviously. So here it goes, that the given now would be, the given step now, or the process, it would be x to the 4 raised to x raised to 4 times the quantity of 3x squared plus 2 raised to the quantity of negative 1 half times 12x squared plus 8 minus x all over quantity 3x squared plus 2 raised to 1. And so I just arrange this one here, this one, because it is in the form of the quadratic trinomial expression. So therefore, I have to arrange it in order. So we have now x raised to 4 times the quantity of 12x squared minus x plus 8 all over, since we have 1 here, subtracted 2, wait, okay, since this one here, this 3x squared plus 2 in the numerator will be removed and put the 2 there in our denominator, so it became 1 plus 1 half, because they have the same base, add the exponent. So therefore, as you can go along with the next step, 1 plus 1 half, and that is 3 halves. So then, since 12x squared minus x plus 8 cannot be factored anymore, so we just only distribute the x raised to 4 from the left, from the first factor, then be able to distribute the x raised to 4 in every term in the second factor. So we have now x times 12x raised to 4 times 12x squared, it became 12x raised to 6. X raised to 4 minus x, x raised to 4 times negative x, it became negative x raised to 5. X raised to 4 plus 8, it became 8x raised to 4 all over 3x squared plus 2 quantity raised to 1 half. So since we cannot have any more we cannot get any more the simplified term on this expression, so this is now our final answer. Sorry, wait, let's remove this one. Okay, so this one would be our answer from the given expression. So then again, in this case, here's the tip in working with the rational exponent for the complicated example. So all we have to do is try to understand first what is the basic thing that we should do, and we have in getting the common factor, or try to get first the greatest common factor in every numerical coefficient, collect all the numerical coefficient and make use of the continuous division for you to be able to identify what would be the greatest common factor, and then multiply the left side, those common divisors multiplied, then we have to get now the greatest common factor. And in the variable given, if we wanted to identify its greatest common factor in line with the variable that we have, all you have to do is try to get the lower value of the given exponent. So that would be the tip in dealing in how to simplify rational exponent given the same kind of the problem that we have. So hope you like it, the discussion. If you want to if you want to know further, feel free to have some comment and have to suggest whatever things or the discussion you want to discuss. But then don't forget to try to follow my Facebook account, and that is humble.math.143 for my FB page, and Humble Math Easy for my YouTube channel. So hope you like it. See you then. Goodbye. Thank you.